A very good afternoon, student. Welcome to the class. I'm Chinmay. I'm working as a program associate in JMU Hassan. So today I'll be taking your class. So yes, we'll wait for a while for the schools to join and the students to join. Then after that, we'll proceed with our class. Okay. Okay, I'll be launching the poll right now. So please do respond to the poll so that I can know whether I'm clearly audible and the screen is clearly visible to you all. Okay. And the YouTube people, please do respond in the chat box so that I can know I'm clearly audible to you all. Right? Okay. Okay. Good afternoon, students. Okay. So then let's begin with the class. I can see that there is no any disturbance. I think I'm clearly audible to you all. So we'll begin with our class. So in our today's class, we'll learn about the differentiation. So let's see what are things that we're going to learn in our today's class. First, we'll see what is differentiation. We will see what is the physical meaning of differentiation as well as geometrical meaning of differentiation. And after that, we'll see what is first principle of derivative. And we'll solve some problems based on this principle. And after that, we'll see rules of differentiation. Like if we have two derivatives, how to add two derivatives, how to multiply them, how to divide them, that all things we will see here in the rules of differentiation. Okay. And after that, we'll solve certain problems based on it. So this is the brief overview of our today's class. So if it is clear, so let's begin with our today's class. Well, okay. So now we will see differentiation. We'll see what is physical meaning of differentiation as well as geometrical meaning of differentiation. Okay. Well, see, first, differentiation is nothing but it's a rate of change of one function with respect to some other variable. Okay, it's a rate of change of one quantity with respect to other quantity. Here we are studying differentiation with respect to functions. Okay, so what I'll do, I'll consider one function. So let's consider function y is equal to f of x. Okay, fine. Here y is known as what? It's known as dependent variable. Okay, and this x is nothing but this x is independent variable. Why y is known as dependent variable? Because whatever changes happen in the y, it is due to x. If x changes, the value of y will change. Hence, it's dependent on the x. Okay. So if we consider function y is equal to f of x, then the physical meaning of differentiation will be it represents the instantaneous rate of change at that point. It represents the instantaneous rate of change of function, that is f of x, at a given point. Say at x is equal to some. If you want to find a differentiation at x is equal to 1, then it will represent instantaneous rate of change of that function at that point. Now, what is this instantaneous rate of change? This instantaneous rate of change is nothing but it's the rate of change at particular point. Okay. While finding average change, what we will do? We will take initial point, final point, and then we'll find the average change. But here we find a change at a particular point. Okay, single point. Right. So this is the physical meaning of differentiation. And yeah, the geometrical meaning of differentiation is it represents the tangent to a curve at a particular point. Okay, this differentiation, it represents the tangent to a curve at a particular point. Okay. So as I consider x is equal to a here, so let me take x is equal to a. Fine. Okay. At x is equal to a, tangent to a curve at x is equal to slope. Sorry, slope of a tangent. I'm sorry. Fine. So we represent differentiation usually by f dash of x or dy by dx, also df by dx. Okay. So these are the terms used to represent the differentiation. Okay. Well. Yes. Any issues? If you have any issues, then please drop text in the chat box. Okay. Fine. Okay then. So let's move ahead. So wait a minute. Okay. So next, we were discussing about the geometrical meaning, right? It represents the slope of a tangent to a curve at x is equal to a. So how we can represent geometrically? Now let me consider some function. Okay, say f of x. It's a curve. It's a curve. I'm calling this a function f of x. Now what I'm doing? I'm just considering one point at this function. So say x is equal to a, okay? And I'm drawing tangent to this curve at this point, okay? Tangent to the curve at this point. This tangent, nothing but it represents the differentiation of this function at this point, okay? This is the geometrical meaning. Is it clear to you all? Any doubt in this? Okay. Okay, fine. If it is clear to you all, then we will move it. Right? Next. So next we will see this geometrically how we represent differentiation. We got to know that slope of the tangent represents the differentiation. But how usually we find the slope of the tangent? By considering 2 points, right? If you have 2 points, we make use of our formula y2 minus y1 divided by x2 minus x1, and we find the slope of the tangent. But here we have only 1 point. Now how to find this? So let's see how to compute this differentiation, okay? That we will study in this slide. For that, we have considered some arrangements here. So I have considered a function f of x. So let this function, the curve that you can say here, the red curve, we call it as what? F of x. Let this be a function f of x. And we considered 2 points on this function, this curve, that is point P and point Q. I think you can observe, see this, okay? Let coordinate this of point P be a comma f of a. Why? Because the x-axis value is a and the y-axis value is what? F of a. Okay. Then I consider the one more point Q. Here, the coordinate of this point Q is what? A plus h, comma f of a plus h. Okay. Because x value is what? F of a plus h. Y value is, sorry, x value is a plus h and y value is f of a plus h. Okay. So these are the 2 points. Now tell me, when 2 points are given to us, and yeah, I'm drawing one line through this point, PQ. This is nothing but a second. This line PQ, which is cutting the curve. See, you can observe here, the line PQ is completely cutting the curve. So whatever the line which cuts the curve, we call it as what? We call it as a second. So PQ is what here? PQ is nothing but it's a second. Right? Now tell me how to find the slope of the second. Yes. Slope of the second. When leave second, line. It's a line, right? How to find the slope of the line when 2 points are given to us? Yes. Tell me. We know 2 points, P and Q. We know their coordinates. So how to find the slope of this slope of that line? PQ. Yeah. Well, When 2 points are given, x1, y1, comma, x2, y2, how do we find slope? We find slope by considering the formula y2 minus y1 divided by x2 minus x1, right? Correct? So I'm making use of same thing here. The 2 points here are P with a coordinate a comma f of a, and Q with the coordinate a plus h comma f of a plus h. So the slope of the second will be what? F of a plus h minus f of a, that is y2 minus y1 divided by a plus h minus a. So what we will get? We will get f of a plus h minus f of a divided by h. Okay. So this will be the slope of the second. But what is our goal? What we have to find here? Tell me. What actually you are finding? You are finding slope of the tangent at a given point. Okay. Here that point is P. Okay. We are finding slope of the tangent at point P. Okay. Now tell me, what can we do? Just observe this graph. Here, as Q move towards point P, what will happen to this line? PQ, tell me. As this point Q, it's moving along this curve towards point P. So what will happen to this line PQ? Yeah. So what happens is here, that line PQ will coincide with this tangent at the point P. Okay. So what happens? As point Q move towards P, the second becomes the tangent to this curve at the point P. Okay. The second becomes the tangent to the curve at the point P. Therefore, second PQ will convert into tangent at P. So as Q move towards P, second PQ becomes tangent at point P. Fine. So is it clear to you all? Any doubt in this? Tell me. Any doubt in this? No, right? Okay then. See, now yes, this much we understood. Next, what happens to this as Q is moving towards the P? What will happen to this A plus H? It will move towards this A, right? Yes. A plus H will tend to what? Value A here. This A plus H will tend to what? Value A. Okay. So as A plus H tends to A, what will happen to H? This is the H value. This distance is nothing but H. It becomes 0. Yeah. As A plus H is moving towards A, H will tend to what? 0. Okay. It will become 0. So is it clear to you all? Any doubt in this? Yes. Well, if it is clear to you all, then now we'll go to the next part. Well, now we want to find slope at this slope of this tangent at the point P, right? So what will be the slope of the tangent? Slope of the tangent will be equal to limit as h tends to 0, f of a plus h minus f of a divided by h. Why have I written this? Tell me. I have written this because as h is tending towards 0, our point Q is tending towards what? Point P. Hence, our second is converting into what? Tangent to this curve. Okay. That's the reason. Slope of the tangent will be what? Limit as h tends to 0, f of a plus h minus f of a divided by h. Okay. Remember this. So this is nothing but, we call this as, and we know slope of the tangent is nothing but differentiation, right? So we can represent it as what? We can represent it as f dash of a, correct? Differentiation of that function at the point A. So differentiation of the function at the point A is nothing but limit as h tends to 0, f of a plus h minus f of a divided by h. Okay. Fine. So I hope this is clear to you all. Okay. So we'll move ahead. So next is first principle of derivative. This is something similar. See, whatever we have derived here, the same thing that we are mentioned in this next slide. Okay. Okay. So first principle of derivative states that derivative of function f of x at x is equal to a is f dash of a equal to limit as h tends to 0, f of a plus h minus f of a divided by h. Okay. So previously, whatever we derived in this geometrical meaning, same thing. So that is nothing but it's known as first principle of derivative. Okay, it represents the first principle of derivative. So is it clear to you all? Any doubt in this? Just remember this, okay? This is statement. Using this, we can find derivative of function at different points. That we will see in the next slide. We'll see one example also. Okay. So yes, no doubt, then we'll move ahead. Next. So let's see one example. Fine. So this question here is, use first principle method to find the differentiation of x squared at x is equal to 1. Okay. Now tell me, what is first principle method? Yes. In the previous slide itself, we have seen it, right? It states that derivative of function at x is equal to a is given by limit as h tends to 0, f of a plus h minus f of a divided by h. Okay. Now what is f of x here? Tell me. Yes. F of x is nothing but x squared, right? So what will be f of a plus h? F of a plus h will be a plus h whole square. And f of a will be what? F of a will be a squared, correct? So just substitute these values here, fine? Just substitute these values. So what we will get? We will get f dash of is a is equal to limit as h tends to 0, a plus h whole square minus a square divided by h. Okay. Now they already given a point here, x is equal to 1. So in the place of a, what we are doing? We are substituting value 1. So it is nothing but f dash of 1 equal to limit as h tends to 0. Observe here, it is of the form a plus b whole square. So apply the identity. We will get 1 square plus 2ah plus h square minus, in the place of a substituting 1. So it's going to be 1 and then 1 square divided by h. Okay. Observe here, this 1 minus 1 get cancels. And what we will end up with? We will end up with limit as h tends to 0. Yes, take a h common. 2 plus h divided by h. Okay. H get cancels. Now apply the limit and tell me what we will get here. What will be the answer? Yes. Just apply the limit. What will be the answer? H is tending to 0. So what we will do? We will substitute 0 in the place of h. So we will get answer as 2. Correct? So differentiation of x squared at x is equal to 1 will be what? It will be equal to 2. So is it clear to you all? Any doubt in this? Yes. So please text me in the chat box if you have any queries. Okay. Well, I can see that there are no questions. So we'll move ahead. Next. So next we will see some basic standard derivatives. Okay. So here we have a function y. So we will see what will be the derivative of that function. Fine. So what if we have a constant function? When we have a constant function, derivative of that function will be 0. Okay. Why it will be 0? See, how do we represent a constant function? This is a constant function. That line will be y is equal to k. If I consider that it will be a line parallel to the x-axis, right? Yes. What will be the slope of the line parallel to x-axis? If I draw any tangent to this point, slope of the tangent will be also parallel to x-axis. So slope of that tangent will be what? 0, right? Therefore, dy by dx will be what? 0. Okay. Similarly, we have different polynomials and their derivatives here. So if a function y is equal to x, then derivative of that will be what? 1. Okay. Okay. And if the function y is equal to x squared, the derivative of that will be what? 2x. Okay. And if the function y is equal to x cubed, So derivative of that will be what? 3x. Now observe here, you can find some pattern over here that when x is 1 power 1, derivative of that is what? 1. When x is power 2, we have derivative as 2 into x power 2 minus 1. Correct? And when x is power 3, we have derivative as the power 3 into x raised to 3 minus 1. Okay? So you can find certain pattern over here, isn't it? Okay, there's a question here. The constant function, why it can't be parallel to y-axis, madam? See, why? Because function, we represent function by y, right? See, this is a way we represent function, y is equal to f of x, correct? So now I'm in the place of f of x, what I'm doing? I'm substituting k. So y is equal to k. For simplicity, I consider that constant as 2, okay? Y is equal to 2. Now you can observe here, this y, there is nowhere x in the picture. There is nowhere x in the picture. It's independent of x right now. So whatever the x value is, whatever is x value, y value always take 2. If I take, okay, I'll do it once again. Okay. So, yes, this is 2. So whatever the x value is, it might be 1, 2, minus 1, minus 2, minus 2, anything, y will always take the value 2 here. Okay. Now, join those points, what you will get? When you join those points, you will get a line parallel to x-axis. Okay. That's the reason you will get a line parallel to x-axis, not equal to, not parallel to y-axis. Understood? Is it clear? So you two people, is it clear to you all? Any doubt further? Okay. Well, if it is clear, then we'll move it. Yes, what we were discussing? We were discussing about this pattern, right? You can find certain pattern over here, correct? If I generalize this power to n, then what is the differentiation that we're going to get? We will get power, that is n, into x raised to power n minus 1, okay? So in general, if power of the given polynomial is n, then differentiation of that will be what? It will be n into x raised to n minus 1. Okay, so please do remember this. Okay, these are the important derivatives. So we're gonna make use of this derivatives in future frequently. So please do remember them. So now let's go to the next slide. Next, yes, we have function. We have some more functions here, like exponential, logarithmic, and trigonometric functions. If I consider exponential function e raised to x, then dy by dx of that will be what? E raised to x itself. Fine. And if you consider the function a raised to x, then derivative of that will be a raised to x into ln a. Okay. You might ask me, ma'am, how did we find this, like dy by dx? Why it is e raised to x only, e raised to x ln a only? You don't need to worry about that. This is first year. You will learn this chapter again in the second year in detail, like why actually we got e raised to x, a raised to x, ln a, everything, fine? So let's not discuss that all points here. Just try to memorize this thing, that if e raised to x comes into picture, then derivative of that will be what? E raised to x itself. If a raised to x comes into picture, then derivative of that function will be what? A raised to x into ln a. Okay. Similarly, logarithmic function, if I consider ln x, then derivative of that will be what? 1 by x. Now I'm considering trigonometric function, say sin x, cos x, and tan x. So differentiation of sin x will be cos x. Differentiation of cos x will be what? Minus sin x. And differentiation of tan x will be sec squared x. Okay. So try to memorize these values. Fine. Don't worry, we will study in detail in the next year. Now, right now, try to remember these values. Fine. Okay. So please take a screenshot of this both if you want, so that you can revise it once. Fine. Well then, we will move ahead if there's no doubt here. Next. So next we will see rules of differentiation. What if we have more than two derivatives? Like what if you have more than two functions, say f of x plus g of x? Now how to differentiate this function? What if we have product of the function, say f of x into g of x? How to differentiate it? What if we have a functions in the quotient form, how to differentiate it. So all those things we will study here in the rules of differentiation. Right? We will see the addition, subtraction rule, constant rule, product rule, and the quotient rule. Okay. Well, then let's begin. Next. Well then. So addition, subtraction rule. So what does it state? Here we have two functions, okay? F of x and g of x. These are the two functions. Now, these functions are in the form of addition, say f of x plus g of x. Now, how to differentiate it? So when we differentiate this function, we can split the derivative, okay? So if the function is of the form f of x plus g of x, and if we are differentiating it, then we can write it as differentiation of the first function plus differentiation of the second function, okay? So is it clear to you all? This is the addition rule. If we have any function in the form of the sum or difference, then we can write it as the differentiation of the first function plus differentiation of the second function. Here we have an example too. So yes, we have d by dx of sin x plus x squared. Okay, we can write this as, you can observe here, differentiation of first function, that is sin x dx, plus differentiation of second function, that is x squared. Okay, this is the first function here, this is the second function here. We can split it and write it. Now what is differentiation of sin x? It's nothing but cos x. We have previously seen it, right? And differentiation of x squared, it's nothing but 2x. So this we have seen in the previous slides, right? Therefore, differentiation of this whole function sin x plus x squared will be what? Cos x plus 2x. Okay. So this is the value. So is it clear to your addition and subtraction rule? Any doubt in this? Yes. Okay. Okay, if there is no doubt in this, we'll move ahead. Next. Okay, next we will see constant multiple rule. What is this constant multiple rule? Let's consider one function f of x. Okay, let's consider only one function f of x. We are multiplying some constant to that function, say k into f of x. So when we differentiate that function, we can take that constant outside the differentiation. You can observe here, d by dx of k into f of x will be what? K into differentiation of f of x divided by dx. Correct? That is nothing but what we are doing here. We are just taking this constant out of this derivative. This is what the constant multiple rule states. Whenever a constant value is multiplied to the function, we can take that constant value out of the derivative. We don't need to derive. We have to take it outside and we differentiate only the function. For example, we have an example here. Differentiation of phi x squared. Phi is constant here and x squared is a function, right? So according to this rule, what we have done? We took phi outside the function derivative and we differentiated x raised to 8 here. Okay, phi as it is. What is the differentiation of x raised to 8? It's nothing but 8 into x raised to 7. Why? Yeah, why? Because we made use of this formula, derivative, right? Our standard derivative. That is differentiation of x raised to n is nothing but n into x raised to n minus 1. Here when n value is for 8, so 8 into x raised to 8 minus 1. So it's gonna be 8 into x raised to 7. Okay. So our final answer will be what? Our final answer will be 40 into x raised to 7. So is it clear to you all? Any doubt in this? Yes. Yeah. If any doubt, please text in the chat box. Okay. So if no doubt, then we'll move ahead. We'll see the next rule. Okay. What is the next rule? Next rule is quotient rule. Okay. Yes. Next rule is what? Quotient rule. Okay. So what we will do when functions are in the numerator and denominator, fractional form. Okay. What to do when the functions are in the quotient form, like f of x divided by g of x. In this case, what we will do is, we will write denominator as it is and square. And in the numerator, we consider the second function. Let this be first function and this be second function. We will consider the second function into differentiation of the first function minus first function into differentiation of what? Second function, okay? Just try to remember this, okay? Try to remember this formula, whatever we have. So if our functions are in the quotient form, that is f of x by g of x, how do we differentiate it? What we will do is, we will consider the second function first, yes, as it is, into differentiation of the first function, minus, we will consider the first function into differentiation of what? Second function, divided by g of x squared, right? So in simple words, we can write it as u by v. So I just represented f of x as u by u and g of x as v, and we can write it as v into u dash. U dash is nothing but derivative of that function, right? Minus u into v dash divided by v square. So these are another representation of this. So no need to remember all these three. You can remember one which is comfortable to you. Okay. Just try to remember this formula. Right? So let's consider an example also. Let's say d by dx of, yes, x square divided by e raised to x. So this is the function we have. So how to differentiate it? Tell me. Tell me. Just try to differentiate it along with me. What we will get? Second function, that is e raised to x as it is. Then differentiation of the first function. Differentiation of the first function, x squared. Fine. Minus first function, that is x squared as it is. Then differentiation of the second function, e raised to x whole divided by e raised to x whole square. Okay. So e raised to x as it is. What is the differentiation of x square? Tell me quickly. Yes. Send the answers in the chat box. What's the differentiation of x square? Just in the previous slide itself, we have learned it. So differentiation of x square is nothing but 2x, right? 2x minus x square as it is. What is differentiation of e raised to x? It's exponential function. So what's the differentiation of exponential function e raised to x? Tell me. So differentiation of e raised to x is nothing but e raised to x itself. Okay. Divided by e raised to 2x. E raised to x whole square, right? We can write it as e raised to 2x by using the properties of exponents. Right? So is it clear to you all how to make use of this quotient rule? Any doubt in this? Any doubt? Okay. So please, if you have any doubt, then please to reply in the chat box. So text your doubt in the chat box. Okay, then if no doubt, we'll move it. We'll go to the next one. Okay. Fine. So the next one is what? Next one is product rule, okay? Product rule. So what is product rule? Product rule help us to find the differentiation when two functions are in the product form. Say let's functions are in the form f of x into g of x, okay? So how to differentiate it? What we're going to get when we differentiate it? So when the functions are in the product form, the differentiation of those functions will be what? F of x into this first function, correct? And this second function. So when two functions are in the product form, differentiation of that will be first function as it is into differentiation of the second function g of x plus second function as it is into differentiation of the first function, that is f of x. Okay. So this is how we differentiate the functions which are in the product form. Fine. So let's consider one example also. For example, let's take differentiation of sin x into e raised to x. Okay. Sin x into e raised to x. Now how we will differentiate it? Here you can observe this function is in the product form. This is our first function. This is our second function. Now tell me how we can differentiate it. Let me know the answer. Let me know the answer in the chat box. Yes. So according to this rule, what we will do? We will consider first function as it is, then differentiation of the second function, that is d by dx of e raised to x, plus second function as it is, then the differentiation of what? First function, that is sin x. Okay. Now sin x as it is. What is differentiation of e raised to x? Tell me. Differentiation of e raised to x is nothing but e raised to x only. Okay. Plus e raised to x. Differentiation of sin x is what? Yes. Tell me quickly what is differentiation of sin x in the chat box. Yeah. Come on. Yes. Tell me quickly in the chat box what is the differentiation of sin x. Zora, DPMK, there's some students joined. So tell me what's the differentiation of sin x? So differentiation of sin x is nothing but cos x, okay? Well, now I can take e raised to x common here, right? So e raised to x, if I take common, I will end up with sin x plus cos x, fine? So this is the differentiation of sin x into e raised to x. So is it clear to you all? Any doubt in this problem? Yes? Any doubt? If you have any doubt, please text in the chat box, okay? So let me know. Okay. Okay, if there is no doubt, we'll move ahead with the next part. So now let's summarize all the things that we have learned till now. Till now, we have learned about the rules of differentiation as well as some standard derivatives, right? So we have learned that differentiation of the x to the power n will be what? N into x raised to n minus 1. That is power into x raised to power minus 1. Okay, fine. Then algebra. We also learned about the derivatives, like standard derivatives like trigonometric functions, exponential function, logarithmic function. Please do revise it once. Fine. Well then, and we learned the addition and subtraction rule, like how to find the derivative of functions which are in the addition form. We also learned about the product rule, where we learned how to find the derivative of functions in the product form. And here in the quotient rule, we learned how to find the derivative of the function in the quotient form, okay, when they are in the fractional form, how to find its derivative. So I hope these all things are clear to you all. If these are clear to you all, please text in the chat box. We can move ahead. Yes. Okay. Okay, then if this is clear to you all, then we'll move to the next part. Okay. So let's move to the next one. Now, next is chain. Well, till now, what we have done, we have learned how to derive the standard functions which are in the standard form, right? Like sin x plus cos x. Well, these two functions are in the there are two functions which are in the addition form. But observe the sin x is also in the standard form, cos x is also in the standard form. But what if we have functions like sin x whole square? Yeah. This is not in the standard form. How to differentiate it? Yes. Now the question arises how to differentiate such functions whose standard derivative is not known to us. We know only derivative of sin x, cos x, tan x, that's all. We don't know derivative of sin x to the power 2 and all, right? How can we differentiate it? So here a chain rule comes into picture. Okay. So before going ahead with the chain rule, first we should know what kind of this function, what are these functions are known as, like the sin x to the power 2. These functions which are of the form like sin x to the power 2, e raised to sin x, and I can say log of x squared. So just observe these three functions. You can find something here. So these are the combination of the two functions, right? You can observe here. Here we have two functions. One is sin x, another is e x. Combining these two, we got e raised to sin x. Here we have two functions. One is x squared and another is sin x. Combining these two, we got this. So what are these functions? These are the functions which are combination of two or more functions. Such function we call it as what? We call it as composite functions. Okay. The functions which are combination of two or more functions, we call them as composite functions. Fine. So these all functions are composite function. So to find the differentiation of composite function, we make use of chain rule. Okay. So let's see what is chain rule is. So in the chain rule, what we do is we differentiate the given function till we get a standard function. How? Now, if I generalize this, I can write this as what? Generally, the composite functions are represented as f of g of x. Okay. How we represent this in this way? You can observe here. Here we have two functions, right? One is sin x and another is what? X squared. Fine. This is f of x and this is what? G of x. Now, f of x is equal to what? X squared, right? In the place of x, what we have? G of x. Just replace x in the place of x, g of x. So f of g of x will be what? Sin x whole square. Correct? So this is how we represent a composite function. Okay. So is it clear to you all what is composite function? Composite functions are the functions within function. They are combination of two or more functions. Okay. So to differentiate this composite function, we make use of chain rule. Well, now let's see how do we do it. Right? Next. Okay, chain rule. You can observe here, this is a composite function, that is g of f of g of x by dx. So in chain rule, what we do is we differentiate this function until we get a standard function. You can observe here. We have d of f of g of x. We are differentiating with respect to g of x into d of g of x by d of x. For example, let me consider this only as an example. That is sin x squared. Okay. If I consider f of g of x as what? Sin x whole square. Okay. Now, first what we will do? We differentiate this function. What we will get? In the place of x, we have sin x. It is of the form x squared, right? Just forget this. What is there in the bracket? It is of the form x squared. So what is the differentiation of x squared? Tell me. Differentiation of x squared is what? Yes. Quickly answer me in the chat box. What is differentiation of x squared? It is 2x, right? So it will be 2. In the place of x, what we have? Sin x. Correct? Into, now, in the place of x, we have something other than x, right? Some other function. So what we do? We differentiate it again. Okay? So when we differentiate sin x, what we will get? We will get cos x. Okay? So this will be the differentiation of this function sin x to the power 2. Similarly, observe here, even in this example, what we have done, we consider sin 2x. There are two functions involved in this, right? One is what? Sin x and another is what? 2x. Correct? So this I consider it as what? F of x and this is g of x. Now, when you differentiate it, when you differentiate sin x, what you're going to get? When you differentiate sin x, you will get cos x, right? But in the place of x, what do we have here? In the place of x, we have 2x. So we write it as 2x. And this 2x is something other than x. Correct? Something other than x. So we multiply and we derive it again. We differentiate it again. So what is the differentiation of 2x will be? It will be 2. Okay? So differentiation of this complete function sin 2x will be what? 2 cos 2x. Right? So is it clear to you all? Is this example clear to you all? Any doubt in these examples? Yeah. So chain rule is nothing but if we have a composite function with us, we differentiate that function until we will get a standard function at the end. Until we will get a standard function. Okay. So we'll solve some more examples so that you can get clear idea about it. Well then, next. See, there are some examples here. Now just try to tell me, just is this function a composite or not? Tell me. At least tell me whether this function is a composite or not. Text me in the chat box. Yeah? Yes. Well, they are composite functions, right? Why? The two functions are involved in this. What is f of x here? F of x here is tan x. And what is g of x here? It will be 2x. Okay. Now, how to differentiate this? What we will do is, we consider dy by dx. Now, forget this 2x, okay? Just forget this 2x. Assume that there is x in the place of 2x. So what will be the differentiation of tan x? Tell me. Yes. Differentiation of tan x is what? Sec squared x. Sec squared x. Okay. I'm not writing x because there's something. So differentiation of tan x is sec squared x. So in the place of x, what do we have? In the place of x, we have 2x, right? So I'll write 2x in the place of x. Now we have the function which is other than x. This 2x is nothing but it's a function. It's other than x. Okay. So what we do? We multiply and we differentiate it again. So what is the differentiation of 2x now? Tell me. Yes. What's the differentiation of 2x? It's nothing but it's 2. Okay. Now tell me, do we have any other function which is other than x? No. We got a constant function. So we'll stop it there. Okay. So this is the differentiation of tan 2x. Clear? Now yeah, quickly solve this and tell me what will be the differentiation of y is equal to sine squared x. Yeah? Yes. Now just I'll let me write. This is a composite function, right? It involves two functions. What are these two functions? F of x is equal to what? X squared, and g of x is what? Sin x. So the same thing that we solved previously, the same thing I have solved it here. So it's the same function. This we can write as sin square x also. Okay. So it is a composite function where f of x is x squared and g of x is sin x. We have solved this previously, so I'll not solve it again. Now here, observe here. This is one more example. Try to do this. Now just try to write like which are the two functions involved in this and try to differentiate it. Yes, try it. Let me know. Yes. Okay. So the two functions involved here are what? F of x is equal to what? Root x, and another function involved is x squared plus 3. Okay. Okay. When you combine this both, you will get this composite function. Fine. Now, what will be the differentiation of dy by dx? Dy by dx will be what? Yes. Differentiation of this function first, f of x. Now, assume nothing is there in the place under root x squared plus 3. Leave it. What will be the differentiation of root x? Tell me. Yes. What will be the differentiation of root x? Root x is nothing but x raised to 1 by 2, right? When you differentiate it, you will get 1 by 2 into x raised to minus 1 by 2. Okay. So differentiation of root x will be 1 by 2 x raised to minus 1 by 2. So in the place of x, what do we have? In the place of x, we have x squared plus 3, right? So I will write x squared plus 3 here. Now multiply. We here in the place of x, we have something function which is other than x. So what do? We differentiate it again. So what will be the differentiation of x squared plus 3 here? Tell me. Yes. What will be the differentiation of x squared plus 3? So differentiation of x squared plus 3 will be what? 2x. Correct? Differentiation of x squared is 2x. Plus constant function. Differentiation of that will be what? 0. Okay. So for final answer will be what? 1 by, I can write it as 2 root x squared plus 3 into 2x. So 2 will get cancelled. We will end up with what? X divided by root of x squared plus 3. So is this clear to you all? Any doubt in this? Yeah. So let me know if you have any doubt in this. So shall you all shall I give an example right now? Can you all solve it? Well then, these are the solutions, same thing. Well, we have two more examples here. So let's just try to solve this example. Let me see. Try to solve this example. Y is equal to sine of x square minus 4. And we have to find what? We have to find derivative of this function. Both the functions are composite functions. So try to find the derivative of this function. Yes. I'll give you 1 minute. So try to find it and let me know the answer in the chat box. Okay. Yes. Two functions are involved in this, right? Which are the two functions involved? One is sine x, another is x square minus 4. So it's a combination of these two functions. So if I write it in the form of f of g of x, how it will be? It will be sine of x squared minus 4. So this will be what? F of x. This will be what? G of x. Correct? It's a composite function. How do you differentiate it? Do it. Well, okay then. Well, yes. Text the answers in the chat box. Okay. So what we will do, we want to find dy by dx. Okay. Now, we have what? Sine of x square minus 4. It's nothing but some function, sine, inside the bracket some function, right? What's the differentiation of sine x? Yes. Differentiation of sine x is what? Yes. I'm getting answers in the chat box. Very good. Well, we'll see what the answer is. Okay. Okay. So differentiation of this will be what? Differentiation of sine x will be what? Cos x, right? Cos. In the place of x, what do we have? We have x squared minus 4. Okay. So I write this x squared minus 4 as it is. Now observe this in the place of x, whatever we have, it is something other than x. It's a function other than x. So what we do? We multiply and we differentiate it again. So what's the differentiation of x squared minus 4? Tell me quickly. Yes, I'll come back to the YouTube guy, girl. I'll come back to you. We'll just solve it and I'll come back to your answer. It's a correct actually. Thank you for the answer. Okay then. So what's the differentiation of x squared minus 4? Tell me. Yes. Yes, YouTube people as well as Zoom. What's the differentiation of x squared minus 4? So differentiation of x squared minus 4 is nothing but 2x. Okay. Well, so that's all. As we had a function other than x, we differentiate it again and we'll stop it there. So what we will get? We'll get 2x into cos of x squared minus 4. So very good, girl. Your answer is correct. I'm getting right answers in the YouTube, so I appreciate you. Well then, so yeah, I'm happy that you people are replying. Okay then. So if this question is clear, then we can move ahead with the next question. This is the next question. So try to solve this next question too. Let me see how many of you have solved it. Yes, try to solve it. Yes. Here also we have two functions involved. Yeah. Okay. Okay. Here are the two functions are involved, right? One is what? Sin x Tell me whether how many functions are involved here? We have sin x, we have x cube, we have 4x. The 3 functions are involved here. Correct? I'll show you how we got it. Observe here. We have sin x. Wait. We have x cube. Correct? In the place of x cube, what we place of x, what they have substituted? They substituted sin. So it's gonna be sin x cube. In the here again in the place of x, what they have substituted? 4x. So it is sin cube 4x. Okay. So it's a composite of 3 functions. So this function is a combination of what? 3 functions. Okay. Combination of 3 functions. Well, let's see how to do it. According to chain rule, what? We have to differentiate until we get one standard function at the end. Correct? So let's start with this. dy by dx. Now, tell me what is differentiation of x cube? Yes. Differentiation of x cube is what? Differentiation of x cube is 3x square, right? It's gonna be 3 into x whole square. In the place of x, what do we have? We have sin 4x. So I write it as what? Sin 4x. Okay, in the place of x, I write it as sin 4x. Now, in the place of x, I have function which is other than x. So what will I do? I'll differentiate it again. Now tell me, what is the differentiation of sin 4x? Yes, differentiation of sin 4x. So I'll differentiate. Let me not write this. We'll directly differentiate. So differentiation of sin 4x will be what? Like, forget that 4x, okay? Tell me differentiation of sin x. What is it? Cos x, right? So cos, in the place of x, what I have? 4x. So I write 4x as it is, okay? Now, again, you can observe here. Here in this place of x, we have function which is other than x. That is, we have 4x. In the place of x, we have 4x. So what we have to do? Whenever we have function which is other than x, what do we have to do? Yes, we have to differentiate it again. Okay, very good, very good. I'm getting answers in the YouTube, so it's very good. Well then, so differentiation of this 4x will be what? 4, right? Okay. So now observe here. We have 4 here, 3, multiply it, it's gonna be 12. I can write it as 12 sin 4x to the power 2 into what? Cos 4x. Okay. So is it clear how we got this sin 4x to the power 3 differentiation? In this, what happened is, in this 3 functions were involved. Okay. Those 3 functions were x cube, sin x, and 4x. Okay. These 3 functions are involved. So we got a 3 multiples here. This one, and this one. Okay. So after computing, we get the answer as 12 sin 4x to the power 2 into cos 4x. So I hope this is clear to you all. And I appreciate all those who are solving it and texting the answers in the chat box. Okay then. So yes, next. This is the solution you can observe here. The same thing. So next, so there are some more problems which are all composite functions. So this problem is going to be your homework problems. So please do try them in your home. Try to find the derivative of these 3 functions. Okay. You can observe all these are composite functions. So what we will do, we will make use of a chain rule. Okay. We make use of a chain rule to solve these functions. Right. So now let's quickly revise what are things that we learned in our today's class. Right. So in our today's class, we started with the differentiation, correct? We started with the differentiation and we learned physical meaning as well as geometrical meaning of differentiation. So what is physical meaning? So differentiation, physically differentiation, it represents the instantaneous rate change of the function at a given point. And geometrically, what does it represent? It represents the slope of the tangent at the given point. We have learned this. After that, we have seen first principle. first principle of derivative, correct? And we derived it using what? Our geometrical representation, right? So if you want to find differentiation of function, say at x is equal to a, then it will be what? F dash of a is equal to limit as h tends to 0, f of a plus h minus f of a divided by h. Okay, this we learned. We have a solved problem based on this. After this, what we learned? We learned about the rules of differentiation, like how to differentiate two functions when they are in the addition form, subtraction form, product form, or in the quotient form, right? We learned all the formulas to calculate it. And after that, we seen some standard derivatives of certain functions, like trigonometric functions, exponential function, logarithm function, as well as polynomial function. Okay. And after that, we see how to derive function if they are in the composite form. Like if two or more functions are combined together, that if we have a composite function, how to derive it. What we did there, we made use of a chain rule. Okay. And we solved certain problems based on that. Correct? So yes. So this is the brief summary of today's class. If you have any doubt, then yes, you can ask me now in the chat box. If you have any doubt about today's class, whatever happened, so you can ask in the chat box. Or else, if there is no doubt, then we'll wind up our today's class. Okay, then if there is no doubt, then we'll wind up our today's class. We'll meet again in the next class. Till then, have a nice day. Thank you.